Dear all, welcome to Civil Services with ZAKI, and today we are going to discuss about the giant pillar of heat. And as you know, it is related to the PT 2024 current affairs series. And as you know, these topics are very significant, and it is related to the geography. So why this topic is significant? So let's understand why this topic is significant. Because diamonds are formed around 100 miles below the Earth crust over billions of years, eventually pushed to the surface to the Kimberlite eruption. So basically, these diamonds form very deep in the earth. So scientists for the decades puzzled over what geological engine that bring heat from the earth's core to cause this eruption. So what are the causes of these heat, and what is the basically region or engine behind these phenomenon? So now, as you know, the use of the supercomputer, so new study uses a geodynamic model designed by the supercomputer that accurately captured kimberlite eruption activity from past 200 million years. So yes, so that's why this news is very significant, because this news is published in the Nature Geoscience. So let's what are the see the what are the today's subtopic. So first, see animation of the giant pillar of the heat, number one. Number two, understand the earth internal history, and also kimberlite and hot bulbs, uh, and pillar of the heat, also transportation of the heat from the deep earth, and also 3D geodynamic model of the earth mantle. So we will discuss all these topic, and also mega question. So mega question for the UPSC-CSE Civil Services 2024, and basically it is the 5 most probable question, as you know, provide you in every video. So that's why these are the very significant. So let's stay with us till the end of this video. We will discuss all these topic, and also please subscribe our channel. So let's see the context. So most diamonds are formed deep inside the earth, brought close to the surface in a small yet a powerful volcanic eruption. So it's a powerful volcanic eruption and a kind of rock. Basically it is called kimberlite. So a supercomputer modeling published in Nature Geoscience, so these eruptions are fueled by giant pillar of heat, and it is rooted around 2900 kilometer below the surface. And as you know, 2900 kilometer is the mantle core boundary, so it's just above our planet core. So let's first we see the animation, and as you know, the animation is the one of the best way to understand anything regarding the science, geography, and all other scientific phenomena. So as you know, you find the diamond. So diamond, as you know, the most precious element, and also uh, most uh, hardest substance on earth. So basically these diamonds are formed deep within the earth, intense pressure and intense temperature. So basically, and reach to the surface by the kimberlite. So this type, so scientists puzzles for the decades. So why these type of the what is the cause of this such type of the heat generation? So as you know, 200 million year supercomputer generation, and basically geodynamic model, uh, basically based on the study of the several millions year. So various geologic rock. So as you see here, this is geologic model, and as you know, the our continents are moving. So you can find the this type of the kimberlite eruption like South Africa, here Canada and all that. So basically it is used machine learning tool and AI geo. Basically it's all related to the data from the various part of the world, like the North America, South America and Africa. So that's why, because it is Kimberlite found in the volcanic eruption, the powerful volcanic eruptions. Uh, so as you know about the volcano and several types of the volcano and the viscosity and the lavas, such type of the see here various type of the volcano and lava. So see here different type. So Kimberlite found basically this type of the powerful eruption. So see here, from core mantle boundary to here. So basically these are found basically South Africa, and these are the very oldest area, and no currently volcanic activity are here, because this is so it is the history of 200 million years old. So as you see here, so scientists put these data on a supercomputer in the Australia Canberra, and finally they found this type of the geodynamic model. So see here, it is 90 million, 20 million and all that, as you know. So that's why these kimberlite are that's why found in the Africa and Canada and all that. So this is one of the significant discovery, or one of the significant understanding about the these pillar of the heat. So let's we move forward and see understanding the earth internal history. So why we need to understand the earth internal history? So see here, understanding earth internal history can be used to target mineral severals mineral reserves, not only diamond. So it's not only diamond but also some crucial minerals like the nickel and also a rare earth element, etc. So these are also one of the significant element or minerals. So we under if we understand the geologic history of the earth, we can easily find the where the this type of minerals found, and where we can uh, mine or to explore these minerals. So let's we move forward. So see here, it is a snapshot of global mantle basically convection model. Basically if you see here, uh, plate boundaries, here subduction zone, also here isochrones. So you can find all these in. So see here, this is basically the edge of the rock, and it is, as you know, it is the cold mantle, and it is the basically different part of the see here global mantle basically convection. So as you know, these plate tectonic, or these basically plate are moving due to the mantle convection. So let's we move forward and understand the kimberlite and the hot blobs. So what is hot blob and kimberlite? See here, kimberlite eruptions have behind a characteristic deep carrot shaped pipe, as we see earlier in the animation. Kimberlite rock which often contain diamond. So remember, not all kimberlite contain diamond, but often most of the kimberlite basically pipe contain diamond. Hundred of these eruptions occurred over past 200 million years and have been discovered around the world. And you can find around the world, including our India, but most of them were found in Canada, 178 eruptions. After that, South Africa 150, Angola 71, and Brazil 70. So these countries are the uh, uh, most frequently and most abundant kimberlite found in these countries. So see map. So see here, Kimberlite eruption in past 200 million. So see here, if you see the South Africa and the neighboring country, you can find these. You can find here Canada and all these areas. You can find 17 in Brazil and all that. You can also find our in India only 7, but you can find in India also. So this is the source. Basically, it is the geodynamics Kimberlite cooling Earth model. So let's we move forward. So between the Earth solid core and molten solid crust and the molten core, as you know, mantle is present, and as we know, the mantle is slightly a goopy hot rock in the ASO. So in 2010, geologists proposed Kimberlite eruptions could be explained by thermal plumes. So as you know, the thermal plumes and all that, as we know, if you want to know what is thermal plumes and all hot spot and etc, then you must watch our previous video in our channel, uh, like the hot spot and all, like this video and all that. So basically, these two deep hot blobs anchored under the Africa and Pacific Ocean. Basically, scientists found these two blobs. So see the pillars of heat. So what is the pillars of heat? And basically, it is the new finding of the pillars of heat. So pillars of heat are broad mantle upwelling. Basically, if you can, it is called broad mantle upwelling, and you can call it pillar, pillars of heat. So that connect the Earth's surface to the deepest region. So these pillars are rooted, have the planet's core mantle boundary 2,900 kilometer below the surface, and also crest stretch 18,000 mile below the Earth's surface. The idea of pillars is not so new, because as you know, the plate tectonic and all these came into the existence in the 70s and late 60s and after 70s. So the idea of pillar of heat was first explored in the 1970s, and the result of the supercomputer after, as you know, the supercomputer calculation were published in 2023 in the journal Nature. So supercomputer or such type of the technology basically is the problems of the humanity, and the years, basically the years come into the day and the hours. So these type of the supercomputer calculate these 200 million year millions Earth history data. So see here, this is the Kimberlite. As you know, it's look like the carrots, and it is mantle plume. As you know, basically it is from the, as you know, it is the core mantle boundary. It is 1860 kilometer, approx 200 2,900 kilometer. So basically it is the giant pillar of heat. Giant pillar of heat. This is giant pillar of heat. These giant pillar of heat fuels these Kimberlite. So basically this is new discovery. It is the schematic presentations of the Earth heat pillar. So as you see, this is heat pillar, and bright that the Kimberlite best output from the geodynamic model. So we see the transportation uh, uh, of the heat deep Earth. So basically it is transportation. So geologists assume that the mantle plume could be responsible for the ignition of the Kimberlite eruptions. So however, there was still a big question. So it is okay, it is transported by the mantle plum. So these mantle plum fueled by which type of the engine? So one big question is, how was heat being transported from deep earth to the kimberlite? So to answer this question, to address this question, scientists use supercomputer in the Canberra, Australia, supercomputer, to create three-dimensional geodynamic model of the earth mantle. So as you see here, 3D geodynamic model of the earth mantle. So what is this model? So these model account the movement of the continent on the surface and into the mantle over the past 1 billion years. So basically data and basically record of the earth history about the 1 billions basically feeded data feeded by these supercomputer, and finally these supercomputer calculated movement of the heat upward from the core and discovered the broad mantle upwelling or pillar of heat. You can call it pillar of heat, and you can also call it broad mantle upwelling. So connect the very deep earth to the surface. So basically this model successfully captured kimberlite eruptions in the Africa, Brazil, Russia, and partly the United States and Canada. United States and Canada. So these basically geodynamic model is one of the significant to discover these pillars of heat. So that's why the giant pillar of heat is one of the uh, news for your civil services examination. So see here, this is the geodynamic model. So basically these 100 billion old data took this area, but basically it is produced by the supercomputer about uh, if you see here about 200 million years. So see here, basically it is the depth of the mantle, and see here it is hot mantle and it is cold mantle. It is subduction depth and it is upwelling from the below about 2900 here to here. So see here, see here. So see here. So after all this discussion, we will provide you the mega question for the civil services 2024. So see these questions. One of the regarded the kimberlite, and another is the kimberlite found in the which type of the country, and third one is the pillar of heat was first explored in which decade, and also the kimberlite eruption. So ignition of the kimberlite eruptions, and five, the transportation of the basically transportation from the deep earth, so heat being transported by the. So these five questions are one of the most significant question you can find in the description box. So go to the description box and for the detailed answer, and also join my specific group, this group. So I hope you will understand all things. So thanks for watching this video. Thanks a lot. We will meet in the next video in the next week. But if you want, if you any student want help us, please help. Thanks a lot again.